In this video, we will review 5 of the substructure enhancements in the latest release of OpenBridge Modeler: pipe piles, concrete pads, the new option for the cap top to follow crown deck, the new Symbology for cheek walls, and rectangular footing offsets. In the new release, pipe piles can be assigned to caps and footings of both abutments and piers, and they take outside diameter and wall thickness as user input and also have the option to be filled with concrete. To assign pipe piles to the cap of an abutment in OpenBridge Modeler, I will select the abutment, go to its properties, and open the Substructure template dialog. In the Piles tab, I will set the pile shape to pipe pile, and here I can specify the outside diameter and wall thickness in addition to the pile length and embed length. I also have the option to mark it as concrete filled, and pile layout can be defined through the pile pattern layout window as with any other pile type. I will click OK to accept the changes, and the pipe piles will be applied to the abutment. I will clear the highlight here. And if I go down to elevation 0, the decorator for the piles will show both the inside diameter and the outside diameter. Now I can repeat the same on the footing of a multi-column pier. So I will select the pier, open its properties, go to Substructure template, then to Piles tab, and change the pile shape to pipe pile. Here I will adjust its properties, and this time I will enable the concrete filled option and click OK. The material for the pipe can be set through the pile material definition in the material section of the properties dialog for the abutment or pier, and the concrete fill will adopt the material of the cap or footing depending on its associated component. I will now turn off all levels except those of the piles. And change the display style to illustration ignore lighting to see the pile materials. For the abutment piles with no concrete fill, only hollow steel pipes are created, whereas the pier piles have concrete fill inside the steel pipes. In the quantities report, pipe piles are listed in the substructure quantities under an abutment or a pier, and the quantity of hollow steel pipes is measured in length units, and concrete fill quantity is expressed as volume. Finally, rebars can be defined inside pipe piles filled with concrete. The second enhancement that we will cover in this video is concrete base pads that can now be placed under abutment and pier footings. Concrete pads, also known as seal slabs, has the material definition option and requires transverse and longitudinal offsets and thickness as user input. To apply concrete pads on the footings of a pier in OpenBridge Modeler, I will select the pier, open its properties, go to Substructure template, and switch to the Footings tab. I can define concrete pads underneath isolated footings as well as combined footings, and also when piles are present. I will scroll down, enable the concrete pad option, and specify the offsets and pad thickness. The offsets here represent the combined length of the extensions on both sides of the footing in each direction, and concrete pads will be placed under the footings when I click OK. Here I applied the same concrete pad for all footings, but it is possible to assign pads with different dimensions to different footings of a single pier. The size of the footings that I used here was 12 by 12, and I set both offsets to 1 foot, so if I measure the length of the concrete pad, I get 13 feet. In the quantities report, concrete pad is listed in Substructure quantities table under the relevant abutment or pier, and its quantity is measured in volume units. The third feature, which is one of the major improvements of this release, is the new option in elevation constraints for the top of cap to follow the crown deck, and it is applicable to all types of caps of both abutments and piers. This new feature works for decks with typical 1 or 2 planes on each side the crown point, and with this option bearing seats and cheek walls can follow the top slope of the cap, but bottom of the cap cannot, and it will be leveled. In the previous release, when the parallel to deck option was selected for the top of the cap, it would match the slope of a line drawn between the bottom key points on the left and right sides of the deck. Now in the new release, when the crown deck option is chosen, the cap top can follow the deck slope when it is crowned, and any cheek walls, bearing seats and steps will adjust to the slope of the cap. I will apply this new feature first on an abutment with step cap. So I will select the abutment, go to Properties, then to Elevation Constraints, and here I will set the top slope of cap to crown deck. I will click OK to accept the changes. The cross section will be updated, and now the top of the cap is parallel to the deck, and the steps are adjusted to accommodate the slope of the cap. Next, I will change the station in the cross-section view to see the pier instead. This is the cap that I will be modifying next. So I go to the Explorer, select the pier, then go into Properties, and in Elevation Constraints window, I will set the top slope to crown deck and click OK. The cross section will be updated. Now the top of the cap has the same slope as the deck. Bearing seats are adjusted to accommodate that, and the bottom of the cap is leveled. I will turn off the deck and beams in Explorer to see the change in 3D as well. So this is the resulting abutment with step cap, and this is the pier with bearing seats. And here is an example with a more complex deck geometry with 2 planes on each side of the crown point, and the cap can also follow that, and the cheek walls and the bearing seats will follow the cap. The fourth enhancement of this video is the new symbology of cheek wall. In earlier versions it was sharing the same symbology as the pier. In this release, if I go into OpenBridge standards in the Explorer and view the properties of the pier feature definition, I will see the new cheek wall template, and it will be the same with the abutment. So if I view the properties of the abutment definition, I will have a new cheek wall template. The fifth and last enhancement that will be covered in this video is the rectangular footing offsets. This new feature is applicable to rectangular isolated footings only and take transverse and longitudinal offsets as user input. To apply offsets to the rectangular isolated footings of a pier in my model, I will select the pier, open its properties, select Substructure template, and inside the Footings tab I will scroll down and specify the transverse and longitudinal offset values. They can be positive or negative. I click OK here, and the model will be updated to reflect the changes. I need to clear highlight, and now I have eccentric footings under each column. It is also possible to assign different offsets to each footing of a pier. To do that, I will go back to Substructure template, and in the Footings tab I will click on the Add Pattern button to add a new footing definition. Here I will set the column to column 2 and adjust the offsets for the column 2 footing. And then I will repeat the same for column 3 footing. I will go down, change the column to column 3 and assign the offset. I will click OK, the model will be updated, and now each footing is positioned differently.